So now this is a summary of the 4 types of feedback amplifiers. So see here, voltage series, current shunt, voltage shunt. So what is the output I am sampling? X naught. Voltage series, so I am sampling voltage. Current series, so I am sampling current. Sampling is at the output side. Current shunt, so I am sampling current. Voltage shunt, so I am sampling voltage. What is the mixing network? What is the mixing network? What is the X naught is the output, XS, XF and FD. XF is the feedback and XS is the input signal, correct? So series means my voltage is additive. Current series means again voltage is additive. Current shunt, so in shunt current is additive. Again voltage shunt, you have the term shunt, current is additive. So voltage series feedback is also called as voltage amplifier. So I'll be measuring what is called as voltage gain. And voltage gain, you know, it is V naught by V in. AV equal to V naught by V in. Okay. And the current series amplifier, I told you it is called as a trans conductance amplifier. So I measure GM. GM is given by I naught by V in, output current by input voltage. Okay. Current shunt feedback is a conventional current amplifier. So I'll be measuring what is called as current gain. Current gain is given by I naught by IN. I naught by IN. Okay. It's a current amplifier. And last one, voltage shunt. It is a trans resistance amplifier. So RM you will find RM is equal to V naught by II. Okay, so these are the different parameters what you calculate once a problem is given. They say voltage series feedback amplifier, then essentially you should have a mentality and find out the voltage gain, because voltage series feedback is predominantly voltage gain amplifier. It is going to provide voltage gain. Current series feedback amplifier will predominantly have transconductance GM. Current shunt feedback will predominantly have current gain, larger current gain AI. Voltage shunt feedback amplifier will have trans resistance. So trans resistance is given by RM. So now, having known what is the amplifier, for all amplifiers we will not be measuring voltage gain, current gain, no, because each amplifier has its own parameter to be measured or calculated, right? So we have to find out that first. Rather than measuring voltage gain and current gain for all amplifiers, first measure that parameter which is significant for that amplifier. For current series amplifier, you have to specifically find GM. Finding voltage gain may be secondary, but primary thing is measuring GM. Okay. Next one, the feedback factor beta. See, remember this beta depends on A, and this beta is almost 1 by A. So you see here, A expression, you know, for AV, it is V naught by VI. Take the reciprocal, you get VI by V naught, replace I by F. So it is VF by V naught. Remember, A and beta are reciprocals. Only thing, after reciprocating A, you should replace I by F, because it is the feedback voltage is going to be the output of your feedback network. Same way for GM, current series feedback, beta is going to be take the reverse of GM. So beta is going to be VI by I naught. You have to replace I by F. So VF by I naught. VF by I naught. You see, in the tabular column also we are getting the same values. These shortcuts nobody will teach you, or even you cannot decode from the book. You have to understand these shortcuts whenever it is taught, and you remember it. And AI, I naught by II. When you want to find beta for this amplifier, take the reciprocator. II by I naught, you should replace II by IF. So it is going to be IF by I naught. Okay. And last one, voltage shunt. You have RM as IF by V naught, take reciprocal. So you will get V naught by IF Okay, so you will get, sorry, V naught by II. Take the reciprocal, you get II by V naught. You have to replace I by F, so you get IF by V naught. So this is how you can write the expression for beta without even by hearting. So beta and A are related. A means you don't think it is always gain. In feedback amplifier, A can take 4 possible dimension. One is voltage gain, current gain, trans conductance, and trans resistance. So depending on what is your A, reciprocate A, just replace I by F. That is the logic how to find the feedback factor beta for your feedback amplifier. Anybody is having doubts in this table? Anybody is having doubts in this table? No doubts. See, everything depends on what is the A which you are finding. So depending on A only, your beta value is going to